Assalamu alaikum. Today we discuss chemistry chapter 10 section 5 water. Objectives of our lesson: to describe the structure of water molecules, discuss some physical properties of water, explain how the physical properties of water are determined or related to the structure of water, calculate the amount of energy absorbed or released when quantity of water changes state. The structure of water. We know that water molecules consist of two atoms of hydrogen and one atom of oxygen linked together by polar covalent bond. As you can see, here one oxygen atom in red color and two hydrogen atoms in blue color are linked together by polar covalent bond, single polar covalent bond. And the water molecules are linked by hydrogen bonding. As you can see in the figure, here the first molecule is linked to the second one by a type of bond called hydrogen bond between one atom of hydrogen of a certain molecule and the oxygen atom of the second molecule. It's called hydrogen bond. So this link is called the hydrogen bond between two molecules. And the second is linked to the third one, and so on. This is called hydrogen bonds. The number of linked molecules by hydrogen bond decreases with increasing temperature. As the temperature increases, the bonds start to be broken. So the number of linked molecules decreases. The hydrogen bonds between molecules of liquid water at zero are fewer and more disordered than those between molecules of ice at the same temperature. If you have ice at zero and water at zero, so you find that the number of hydrogen bonds linked molecules of water are fewer than the number of linked molecules in ice. As the temperature increases, water molecules absorb enough energy, so they break up into separate molecules. And the rate of breaking up increases and becomes maximum at the boiling point. So the water molecules start to vaporize. Physical properties of water. The first property of water is that at room temperature, pure water is transparent. You can see through, odorless, tasteless, no taste, and almost colorless, no color. So pure water is transparent. You can see clearly through, odorless, no odor, tasteless, and almost colorless. Water expands as it freezes. Because the molecules in ice are arranged in a hexagonal arrangement or hexagonal pattern. As you can see in the figure, here water is the first in the left figure, the water molecules, and in the right, ice molecules. You can notice that in the right, ice molecules are arranged, take a hexagonal pattern, a specific shape, while water molecules are not arranged. So the ice molecules take larger space, larger size. So the hexagonal arrangement causes the molecules to take a larger space or larger volume. So the density of ice is less than that of water. The density of ice less than the density of water because the molecules of ice take a larger space than the molecules of liquid water because they are arranged in a hexagonal pattern or hexagonal arrangement. And this lower density of ice explains why ice floats on the surface of water. We know that ice floats on the surface of water. This is because the density of ice is less than the density of water, and so ice floats on the surface of water. Now, another property is the molar enthalpy of fusion. The amount of heat needed to change 1 mole of ice into liquid water at 0 degrees Celsius is relatively larger than compared with the molar enthalpy of fusion of another solid. This is because of the hydrogen bond. Both the boiling point and molar enthalpy of vaporization to change water into steam are high compared with those of non-polar substances of comparable molecular mass such as H2S. Why? Why the molar enthalpy of fusion and the molar enthalpy of vaporization and the boiling point of water is high? This is due to the hydrogen bonding that must be broken, needs more energy to be broken for the water to boil. So steam or vaporized water stores a great deal of energy as heat. Why? Because to change from water into steam, you need energy. This heat energy is stored in the steam. So steam has a great deal of energy as heat. So if steam is converted into water again, it loses this amount of energy. This figure represents the heating curve of water. As you can see, starting with ice, giving an amount of heat to ice, the temperature of ice starts to increase, as you can see, till it reaches the melting point of ice. Here the curve is horizontal because this amount of heat gained changed ice into liquid water at the same temperature without changing temperature. As the ice is changed into liquid water, the temperature starts to increase again till it reaches the boiling point of water. At the boiling point of water, the curve is also horizontal because this amount of heat is needed to change water into steam or vapor. This is the heating curve of water. Let's discuss an example. How much energy is absorbed when 90 grams of ice melts at STP? How much energy is absorbed also when this same mass of liquid water boils? So you have 90 grams of ice melts. It needs an amount of heat. What this amount of heat? And when this mass boils, what's the amount of heat needed to change water into steam? What's given here? Mass of solid water or mass of ice equals 90. Mass of liquid water equals also 90, the same mass. Molar enthalpy of fusion of ice, 6 kilojoule per mole. So to change 1 mole, you need 6 kilojoule. Molar enthalpy of vaporization of water equals 40 kilojoule per mole. To change 1 mole of liquid water into steam at the same temperature, you need 40 kilojoule. What's the unknown here? Energy absorbed when ice melts and energy absorbed when water boils. Solution. First, convert the mass from grams to moles. We have 90 grams times 1 mole of water divided by 18 grams per mole. So it will give 5 moles of H2O. Use the molar enthalpy of fusion of ice to calculate the amount of energy absorbed when ice melts. So the energy equals 5 moles times the molar enthalpy of fusion, which equal to 6. Each mole here needs 6 kilojoule, and we have 5 moles. So 5 times 6, so equals 30 kilojoule. To convert 5 moles of ice into water at the same temperature, which is 0, the melting point. Calculate the amount of energy absorbed when water boils by using the molar enthalpy of vaporization. The same, we have here the energy needed on boiling equals 5 moles, the mass in mole, the amount, times 40, which is the molar enthalpy of vaporization of water, equals 40. So 5 times 40 equals 200 kilojoules. So this is the amount of heat needed to just change from liquid water into steam at 100 degrees Celsius, which is the boiling point.